Hello, and welcome to my discussion on dynamic bidding for sponsored products. I'm Aditya, and this talk is based on work done at Wayfair with Wanchen Shao, Kurt Zimmer, Matt Lindsay, Jinjin Zhao, Sergey Kolbin, Dongyue Xie, and John David Ravini. In the realm of cost per click auctions on e-commerce sites, the default is based on a fixed bid per product set by the supplier. This causes a lack of discrimination in the value of a click, causing inefficient and misallocated spending on advertising, which further drives the supplier return on ad spend to decrease. Improving this requires some mechanism to identify the value of a click and then to modify the bid accordingly, both in real time. This identification can be cast as an optimization problem of maximizing the value of any clicked product whilst preserving, on average, the advertising cost to the supplier. This is shown in the mathematical expression on the left of the slide, where the first term is the value term, where x is a clicked outcome binary indicator, v is the value to the supplier, and the second term is a constraint that preserves the average supplier cost per click. C is the cost per click here, B0 is the supplier's default bid. Now, the natural expression for V, the value to the supplier, is the estimated supplier product value, something like the price, wholesale cost, or profit per sale, multiplied by the multiplied by the post-click conversion probability of that product. Using a typical Lagrangian approach to this constraint optimization problem, we arrive at a bid scaling factor, that is, a bid multiplier shown here on the right. Under the simplifying assumption of a fixed supplier value from a sale, we get an expression for the bid multiplier purely in terms of the post-click probability of conversion, or the PCVR post-click. This is shown within the first term and the clip part of the bid multiplier, where p hat ija is the current PCVR post click in the auction given all the context surrounding it, and the denominator is the average PCVR post click for that SKU. This is then clipped in practice to arrange alpha min and alpha max, just so that we don't excessively modify the supplier's bid and retain the ability to preserve supplier trust. In practice, our denominator comes from an n-day aggregate of the post-click conversion predictions at the supplier campaign and product granularity, instead of relying on a global baseline, which can distort bids and miss the preservation of the supplier's default bid on average. Out here on the graphs, we show on top the supplier campaign product granularity normalized bid multiplier, which is a type distribution close to one, averaging close to one, where the unit division global denominator results in a bid multiplier that is spread wider and deviates from one. In terms of our actual implementation, our production system, when a real-time auction takes place, a set of contextual features are used to predict the post-click conversion ratio, leveraging a pre-trained lightweight gradient boosting model. This is then normalized by the cached n-day aggregate, which is updated at a regular cadence offline. This is then used to derive the exact bid value based on the computed bid multiplier and the preset supplier default bid value. This segmentation of online and offline caching allows us to keep the typical auction latency well below 40 milliseconds while preserving the added value and constraints mentioned before. Before a live test, this bidding system was allowed to pass through shadow traffic for 2 weeks and was projected to increase click through rates, revenue, conversion likelihood, and supplier return on ad spend, providing a good directional signal to proceed into live testing. We then performed a live A B test on a single surface on a website, allowing us to compare this auto bidding mechanism against the manual bidding alternative. We saw statistically significant improvements on post click conversion rates, click rates, and an increase in the cost per click. Despite the increase in the average price of an advertisement for a product, we saw no significant impact on the return on ad spend to the supplier, which did not reach statistical significance but was directionally positive. With a negligible impact on the total customer conversion rate, dynamic bidding became a rollout candidate. Expanding on this positive result, we extended the test to all surfaces, which maintained its statistically significant positive results on most surfaces, with no negative impact seen on other surfaces or on business KPI guardrails. This has then since been employed to enhance supplier bidding outcomes and customer shopping experiences. Thank you for tuning in to this brief summary of Wayfair's dynamic bidding system and to the organizers.